Hello GATE aspirants, welcome to part 1 of GATE Nuclear and Particle Physics series. Question number 11. The basic process underlying the neutron beta decay is. So for neutron beta decay, we have neutron converting into proton, and along with that electron and antineutrino are emitted. The quark content of neutron is DDU, that is down down up quark, and for proton it is UUD. So that means D is down quark is converting into up quark and plus electron and neutrino. So this will be the underlying equation. So option A is correct. Next question. In the nuclear shell model, the spin parity of 15N is given by. So 15 nitrogen, it has Z, number of protons is equal to 7 and number of neutrons will be 7 plus 8 is 15. So number of neutrons is 8. So that means all neutrons are paired and there is one unpaired proton. So for this, for number of protons equal to 7, so Z is equal to 7, we have 1s 1 by 2, then we have 1p 3 by 2, 1p 1 by 2. This is the series. So here 2, then 3 plus 1 4 here. So 4 plus 2 is 6, one more electron, one more nucleon is remaining, so it will go here. So this will be 1. So the last case is this 1p 1 by 2 1. So that means J is equal to, J is this 1 by 2. So J is 1 by 2. L will be, it is p orbital. So that means L is equal to 1. So parity is equal to minus 1 raised to L. So that is minus 1 raised to 1, that is minus 1. So it will be odd parity. So the ground state, it will be J raised to pi. So that is 1 by 2 raised to minus. So odd parity. So here option A is correct. Question number 13. Match the reactions on left with the associated interactions on the right. So on the right we have strong, electromagnetic and weak. So now for strong interaction occurs between mesons and hadrons. Whereas weak interaction, it occurs between leptons and hadrons. So if leptons are involved, it will be weak. And if they are not involved, then it will be a strong interaction. Now here we have pi meson converting into gamma gamma, so that means it is electromagnetic. So 2 to 2, and then this first one, here we have neutron present, so that means it will be weak. So this is weak and this will be strong. So options are 3, 2, 1. So option A is correct. Next, the ground state wave function of deuteron in superposition of S and D states. Which of the following is not true as the consequence? Not true. It has non-zero quadruple moment. It is correct. The neutron-proton potential is non-central. Correct. Then the orbital wave function is not spherically symmetric. This is also correct. The Hamiltonian does not conserve the total angular momentum. So which statement is not correct, that is asked. So option D is correct. Next, question number 32. If the first three energy levels of 228 thorium-90 are shown below, the expected spin parity and energy of next level are given by. So here we have this formula. We have E2 is equal to what? E2 is equal to J2 plus 1. And if I am taking ratio of this with respect to 1, so E2 by E1, if I am considering this, then it will be simply J1 upon J1 plus 1. This will be the formula. So that means from here I can write E6 by E4. That will be equal to, since it is 6, then it will be 6 upon 6 plus 1 upon 4 plus 1. So that is 6 into 7 upon 4 into 5. So E6 will be 6 into 7 upon 4 into 5 into E4. But E4 is 187 kilo electron volt, and that comes out to be 392 kilo electron volt, which is roughly 400 kilo electron volt. So option A is correct. Next question. The quark content of this is indicated here and the process is given. Considering strong interaction only, which of the following statement is correct? So this is the interaction. Pi minus plus proton gives kappa minus epsilon plus. So this is the case. Now let us consider here the process is allowed because, and here spin and isospin they are considered. So strangeness number, S is strangeness number and isospin is considered. So let us calculate, let us see that. So for strangeness, this is not strange particle, pp minus 1 minus 1. So that means delta S is not equal to 0, so it is not conserved. So strangeness is not conserved, strangeness number is not conserved. And then I3 is Z component of isospin. Now for I3, pi for pi it is minus 1, for proton it is half, minus half and plus 1. So here this is also not conserved here. So delta I3 is also not equal to 0 and it is not conserved. So that means both strangeness number and isospin they are not conserved here, and they are conserved in strong interaction. So in case of strong interaction, S and I3 are conserved. So here option C will be correct. The process is not allowed because delta S is not equal to 0 and delta I3 is not equal to 0. Next question. Consider the operations P are parity and T is time reversal. For the electric and magnetic fields E bar and B bar, which of the following set of transformation is correct? So we have E bar is proportional to 1 upon R square and B bar is proportional to 1 upon R. So this parity will not affect E bar, so E bar will remain E bar and B bar it will go to minus of E bar. So this will be the case. So E is not changing and B is changing. So here in option D. And also E bar and B bar are not time variant. So that means E goes to minus E bar and B goes to B bar. So option D is correct. So these were all the questions from GATE 2010 paper. If you like this video, please give it a thumbs up and subscribe to my channel for more videos. Keep learning.